All right, in this video, we want to derive this function over here, f of x equals to cos 3x over x, but we want to derive it using first principles. In order to do this equation, we need obviously our first principles equations over here, but we're also going to use these two equations to solve the question. Generally speaking, for sine and cos equations, you'll always use these two. So let's get started by subbing in the function into our first principles equation. So that's going to be lim h approaches 0 cos of, I'm replacing this x with x plus h, so it's going to be 3x plus 3h. I'll distribute 3 into that instantly as well, divided by x plus h minus the regular function, which is cos of 3x divided by x, and all of this is divided by h. You also want to put a bracket over there so you're not confused, but that whole thing is being cosed. In the next step, I'm going to do two different things. The first thing is I'm going to use my formula cos A plus B equals to cos A cos B minus sin A sin B, the addition formula for cos, to split this up. So I have cos 3x cos 3h minus sine 3x sine 3h, and then this is divided by x plus h. And over here, I'm going to just rewrite this as minus cos 3x divided by x. And the second thing that I'm going to do in this step over here is I'm going to distribute this denominator for my two denominators over here to simplify things, save a bit of space. I'm going to multiply this x with this h with x plus h. So I have h times x plus h over here. Over here, I just have xh. The next thing I want to do is I want to split these two terms up, but I also want to rearrange it. I want to move the sine term to the front and the cos term to the back, because in the end, I'm going to common factor these two. So I want to have these two terms together. I'm going to split my denominator for these two, but also rewrite and change the order. And the reason I'm doing multiple steps in one step is because I don't want this to take too much space in a test. Generally speaking, if I showed every single step, the solution would take about 2 pages. But I'm trying to squeeze it all in about 1 page so you can kind of fit it in a test. I'm going to write this as negative sine 3x sine 3h divided by h x plus h. Over here, I'm going to write it as cos 3x cos 3h divided by h x plus h. So as you see, I've just split these two terms up and rearranged the order as well. The final term, I'll just write it exactly the same. Now, the next thing that I want to do is I want to split up this lim for this and then for this whole thing separately. So lim, and you know what? I'll do another thing in the same step as well to save us a bit of time and space. I'm going to just move this negative 3 sine 3x outside the lim. Negative sine 3x lim h approaches 0 sine 3h over h x plus h. So all I did was move this negative sine 3x outside because it doesn't have an h term. So the limit will not affect it at all. So I can do that with any constant or any x term. But I can't do it with x plus h because there's an h there. And over here, I'll common factor out cos 3x from this equation here. I'll common factor that outside the lim. I'll put the lim after I basically split the lim of this whole thing here and this whole thing here separately, because that's what I'm going to do in terms of my identities. I want to use these two identities. That's why I'm splitting them up. Over here, I'm just left with cos 3h over h x plus h minus cos 3, oh no, minus 1 over xh. So now I'm getting a lot closer to my identity. In the next step, I can simplify this part over here. I can multiply the top and bottom by 3. And the reason I'm doing that is because to have this identity done, this has to match this. Whatever's being signed has to match the denominator. I have a 3h that's being signed that I can't simplify. So I have to match the denominator with a 3h, which means that I'm going to rewrite this as negative. The 3, when I multiply it on the top, I'll just factor it out as well. And over here, I'll write the 3 on the bottom. So I just multiply the top and bottom by 3, and this x plus h, I'll just put it at the end over here. So I have 1 over sine x plus h. For this part over here, remember this is all being limmed together. I'm going to start by writing the plus cos 3x the same, lim h approaches 0, and over here I'm going to make a common denominator. So I'm going to multiply the top and bottom by x over here, and the top and bottom by x plus h over here, and then I'll have a common denominator. So I have x cos 3h over xh x plus h. So I just multiplied x on the top and bottom. And if I multiply x plus h on the top and bottom here, and I distribute the negative into the bracket, I have minus x minus h divided by xh x plus h. Next step, I have negative 3 sine 3x lim h approaches 0. And over here, I know that this right there is my identity right over here. So I can just turn that into a 1. And 1 over, oh, I don't need the lim anymore. 1 over x plus h is being replaced with 0 over here. So this just becomes 1 over x. And then plus cos 3x lim h approaches 0. Over here, I'm just going to split my denominator for these two terms. So I have x cos 3h over xh x plus h minus x over xh x plus h minus h over xh x plus h. Then I can multiply all of these to simplify it. So negative 3 sine x times 1 is just negative 3 sine 3x, and then the denominator is just x. And over here, I just have cos 3x lim h approaches 0. And then over here, I can cancel these two x's. I can cancel these two x's, and I can cancel these two h's. So I'm just left with cos 3h over h x plus h minus 1 over h x plus h minus 1 over x plus h. So now this is getting really close to this identity right here of cos h minus 1 divided by h. This is really close to that in this step over here. Basically using these two terms. So I want to split these two terms from this one so we can get to this identity over here. So I'll rewrite this as -3 sine 3x over x plus cos 3x lim h approaches 0. I have a bracket over here. Cos 3h minus 1 over h x plus h. I just combined these two because they have a common denominator. And this one, I will write it separately. Or maybe I can just keep it over here. It's honestly not going to be a huge difference. 1 over x, x plus h. Yeah, there's no difference. I'll just keep it here. I won't split them up. So now, again, I have the same issue where this is a 3h, but this is a h. So I need to multiply the top and bottom by 3 so that this matches with this. So I have -3 sine 3x over x plus cos 3x lim h approaches 0. Oh, I put my bracket in the wrong place in these two steps. So I'm going to multiply the top and bottom by 3 in this step. So I'm going to multiply the 3 over here because if I multiply the 3 in the front, I'll have to put it over there as well and down over there as well. I mean, in front, I'll have to put it down here as well. But it's easier for now to just multiply the top and bottom over here by 3. So I just multiplied this individual fraction rather than the whole thing because the step's a bit simpler. So now what I want to do is, remember this 3 exists here, it's not scratched out, the scratch is only for the rest of it. I'm going to just split this up. And just rewrite it as 3 and cos 3h minus 1 divided by 3h times 1 over x plus h minus 1 over x plus h. And now that I've reached this point, I can finally substitute my limit into this part of the question over here. So -3 sine 3x over x plus cos 3x. This over here, lim h approaches 0 with just this part over here is my identity I'm going to use over here, which is just equal to 0. So this is going to be multiplied by 3, oh, there's a bracket here, 3 times, this whole thing is just 0 times 1 over x plus h minus, I don't even need the h because h is 0, so 1 over x minus 1 over x plus 0 is just x, and x times x is just x squared. And final step is just to simplify this. It's just going to squeeze into this page just about. So over here, 3 times 0 is 0, 0 times 1 over x is 0. This whole thing is just 0. So cos 3x times 0 won't matter. And then I have cos 3x times negative 1 over x squared, which is actually going to be minus, not plus, minus cos 3x divided by x squared. And this is my final solution to the derivation of this problem using first principles, this little bit in the corner here. And if you do regular derivation using your quotient rule, you should get the exact same answer. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a great day.